Okay, this is going to be our third video for Unit 4, Day 4 of Algebra 2. This video is going to be very similar to the last because we're talking about inverses, except we're going the other way around. So instead of what are the inverses of exponential functions and using logarithms, we are going to go from logarithmic functions to exponential functions, right? So this one's a little bit different because there's a kinetic way of looking at this. You'll see what I mean in a second. And then there's just the purely logical, algebraic way of looking at this. Um, yeah, so I'm going to go over both in this video. So my prime example I'm going to use is going to be uh, f of x here, right? So if we look at it kinetically, right, meaning with stuff moving around, so f equals log x, right? That of course means log base 10. It's understood, right? Well, obviously we want to flip, so x equals log of f, right? And we want to get f by itself because of course we're looking for f inverse, right? Um, So to do that, right, the kinetic way to look at this is to do what I've shown you before. We can rewrite this equation instead of as a logarithmic equation. We can rewrite it as an exponential equation by following our little arrows here, like what I've told you before, right? So 10 to the x power is going to be equal to f, right? And if we rewrite it that way, right, there we have it. We have our inverse. Okay, and we're done. Okay, another way to have looked at this, right, is not the kinetic way. And some of you are going to like looking at it in one way or the other, it doesn't matter. But the other way to have looked at it is in a simply purely algebraic way, right? So the inverse of log base 10 is exponential base 10. Those will cancel. When I do to one side, I do to the other, right? And of course, we're going to have 10 to the x equals f inverse, right? And we get the exact same thing as if we followed our little um, arrows method that we use to convert between exponential and logarithmic um, equations, right? So whichever method you want to use is up to you. Me personally, my brain works kinetically. My brain likes to see things move around. So yeah, okay, so this next example, we have g is equal to ln x, which means natural log, which means log base e, right? So g equals ln x. Um, we're going to rewrite flipped around, right? So we're going to say x equals ln g. And again, that means x equals log base e of g, right? And if we use the kinetic method, right, we're going to say e to the x equals g. So e to the x equals g inverse now, right? If we use the pure algebra method, okay, well, and I'm just going to have to write this again, right? So if we do exponential base e, right, that cancels with logarithmic base e, and what we do to one side, we do to the other. And we see that we're going to arrive at the same thing. E to the x equals g inverse. Okay? Rightio then. I did not mean to do that. Trying to erase carefully. Okay, so that next example, we're going to start getting a little bit more gnarly. So we're looking at h is equal to 2 times the log base 3 of x. Okay, so I'm going to rewrite. So x equals 2 times the log base 3 of what letter? H. Okay. So we have to work from the outside in here because of this 2. Slightly more complicated, right? So I'm going to divide by 2 on both sides. So now I have x over 2 is equal to log base 3 of h. Okay, so now I'm going to convert. So I'm going to draw my arrows. Right, so we see that 3 to the x over 2 power is in fact going to be equal to our h inverse, right? Now, if we did that purely algebraically instead, Well, I guess I can skip that part. We already did that. Let's skip to this part here. So I've got x over 2 equals log base 3 of h. Okay, so the inverse of log base 3 is exponential base 3. So those cancel. And what I do to one side, I do to the other. Right, so I have 3 to the x over 2 power equals h inverse. We get the exact same thing either way that we do this. Okay. Oh, let me circle so you can tell what color we're using. And we'll go with, no, that looks too close. We'll go with yellow on the next one, last one. Okay, so m equals 1/2 times natural log of x minus 2, all plus 1. Okay, so obviously, first step, flipperoo. So we're going to say x is equal to 1/2 times natural log of x minus 2, all plus 1. Okay, oops, what am I, stupid? Forgot to flip the x. That should be an m. Okay, now we're not stupid. Okay, so then now that I have it flipped, same idea as the previous one, work from the outside in. So I'm going to do minus 1 times 2, and then we're going to take care of the natural log after that. Okay, so minus 1 on both sides. So I have x minus 1 equals 1/2 natural log m minus 2, all plus 1. Oops, not plus 1. Okay, so I took care of that by doing minus 1 just to be clear. Okay, so now I'm going to multiply by 2 to cancel this 1/2. So multiply by 2 on both sides. So 2 times x minus 1 is equal to now ln of m minus 2, right? So we're going to use the arrows. So this obviously is log base e. So e to this power, so this is all of this, is going to be equal to what's inside here. Okay? Now, that's one way to do it. Okay, so I'm going to illustrate both and just show that we're going to get to the same thing. The other way to think about it is log base e has the inverse of exponential base e. These are inverses that cancel, and what you do to one side, you do to the other, right? Either way, we arrive at this conclusion. E to the 2 times x minus 1 is going to be equal to m minus 2. I'll just do an arrow like that to show. Right, and then we're just going to add 2. So m inverse is going to be equal to e to the 2 times x minus 1, all of that plus 2. Oops, I don't know why I'm putting an equal sign. Okay, and I would be done right there. Okay, so just as simple as what we saw in the last video. The only difference is there's multiple ways to go about this. Okay, so if you have any questions over any of this, obviously shoot me an email or come and find me. Goodbye.